about some things that I taught or coordinated a subject called Maths for Engineers Preliminary for about 10 or 11 years, which was a subject that was introduced in 2010 at Western Sydney because of the problems with declining maths levels at the uni. We were getting, in the end, about 60% of the students either had no senior high school maths or only standard maths, were coming in and expecting to study engineering maths. They were expected to be at fairly good level of calculus within the first term. It didn't entirely work, but we did try some things which helped us to maybe engage the students a little bit more, and I think maybe get that storytelling idea happening as well. So the course started with basic algebra, then some trigonometry, and then we got into theory of functions, and then the second half of the term was calculus. But alongside those lectures, I had 3 hours of lectures a week and 1 hour of tutorials, and 2 hours of the lecture time was essentially new material, the content of the course. The other hour I had to devote to a variety of things, some lectures on applications, so taking some of the maths and putting it into an engineering context. We also ran some class tests in those hours and ran some workshops. The MESH team ran workshops for the students to help prepare them for the assessment. That's the wrong side. Try that one. So one of the first things that I did in lectures was throw in a lecture on Fermi problems. Is everyone familiar with Fermi problems? So it was an attempt to make students think more big picture, make them think outside the square, use approximation rather than everything having to relate to a formula that somehow was magically appeared. They maybe had to derive a formula for what they were doing. It helped them develop number sense, problem solving skills, and relate the mathematical theory to the real world. Don't know how well it worked. I think partly because there wasn't a lot of follow-up to it. It was one lecture, but at least for some students, I think it was useful in engaging them in something that was a little bit more, made them a little more inquisitive about what was happening. So a couple of, how many piano tuners are there in Sydney is a very typical Fermi problem. It crops up everywhere. It was interesting. I think the last time I used this, about 2 or 3 weeks later, there was an article in one of the papers saying there was a distinct shortage in the number of piano tuners in Australia. So I was able to go back to the class and say, hey, look, what we were talking about wasn't just an exercise. There's something going on here. And that other one, if everyone in the country needed to be inoculated against a virulent strain of influenza, how quickly could this be done? I forget if I used that just before COVID or right at the start of COVID. But that was an interesting one because the student, they had to start thinking about, well, how many people can a nurse inoculate in a day? How many nurses are there? How many are we graduating? So there was a whole lot of unknown variables that they had to think about. As I say, I'm not sure exactly how well that worked, but it got some students a little bit more engaged in what they were doing. And if anyone out there has questions, please jump in because I can't see any chat here. So unless somebody else in the room's monitoring the chat, happy to answer questions as we go along. The other thing we did was whiteboard tutorials. That was an idea that I got from here at FYI Maths very early in the FYI Maths days of FYI Maths, thanks to Deb. And of course, that gets students working in groups to solve problems, doing practical work and actually doing the maths rather than listening to somebody else doing the maths for them, and helps them with problem solving because they have to improve their problem solving skills. Merryn, do you want to?
Yep, sure.
I'll get out of the way over here.
The students like the whiteboard tutorials. I was interviewing students last year, and a large number of them, I was interviewing engineering students who do whiteboard tutorials in maths, and it was remarkable the number of them that said can we arrange to have these for physics and engineering too, please? So that was nice. All right, so you can see what the title is. So I started tutoring for Don in 2018 and in 2024. So I did 12 iterations of the subject. And when I started, I was intensely frustrated because my students didn't show the improvement that I decided they were meant to. And I'm sure none of you can relate to that. So I started experimenting, and Don experimented in lots of ways too. One of the things that I did find was they completely ignored me. Didn't matter. I would say, I'll do this. And they go, yes, miss, and not do it. And completely ignore me. But they're excessively attentive to their marker. If their marker actually wrote something on their paper, they did it, no questions asked, or they whinged about it and ranted and raved and then did it next time. So when Don's marker left and he asked me if I wanted to, I said yes, because I thought it might give me some influence with the students, which I just wasn't happening as a tutor. So I became their marker.
We also didn't tell them.
We didn't tell them that.
Okay.
Yeah.
So the marker was this horrible person out there.
That's right.
Their tutor.
Exactly. Exactly. So the next few slides are sort of talking
Sorry,
about
I don't understand the
marking.
marker's role. Is there someone who was marking what they were doing in the board tutorial, or completely independent marking their
tests.
assignment? I don't see what the marker would do.
Exams, tests. They had 3 class tests. So the marker marked their class tests, and that was most of their assessment, plus the final exam. Thanks for just shouting like that, Laura. You'll need to, because we can't see the chat from up here. So basically, the scripts that they were submitting for the tests were crap. They were unreadable. It looked like a chicken had walked across. The sample you have here is from this year's final exam for the follow-on subject, and it's not good, it's not bad, it's just typical. It's unreadable, it's awful. And I really didn't want to have to put up with suffering through this. Marking's bad enough without having to try and figure out what's going on there. So I suddenly decided I was really interested in good quality communication, which was one of the subject aims anyway. And, you know, sort of, I think our thinking about this evolved over time as well. And we're sort of, I'm at the point, I want to argue that clear communication facilitates clear thinking. So it's actually a good thing if you can communicate that, or you can, if you've got nicely written solutions, it helps you to think clearly, and the converse as well. And, you know, it's been said, if you can explain what you're doing to your grandmother, who's not a statistician, then you probably actually understand it well enough. So hence we got obsessed with quality written solutions. And this is, was this typical? Yeah. So
when I was teaching the subject, right.
So the obsession actually had an effect, and I started getting this. This was a typical set out. The students. It was interesting. We never got complaints about my marking from the students. They would tell me how horrible the marker was and how they had to spend so much time setting out their work nicely because the marker insisted on it, but never. We didn't get any sort of complaints about it being unreasonable or anything like that.
These tests for the last few years were delivered via numbers. So the students got questions through numbers, and then they wrote solutions, scanned them and uploaded them. They've supposedly done practice of the uploading and scanning.
Yeah.
But as part of the weekly tutorials.
Yeah. All right. So after the test, the students got a set of work solutions that they could compare their work to. They couldn't do it. They just weren't capable of taking their solution and looking at the good solution and being able to then say, oh, this is what I should have done, or this is where I needed to change my work. They just could not make that mapping at all. We also added generalised marker feedback. So there was a broadcast announcement sent out to all of them with the markers as this, that and the other about, you know, these are the things what lots of you didn't understand and you should work on. These are the things that you tended to do really well as a group, etc. I don't think it did much. Maybe it helped some student or two, but there wasn't an obvious uptake. So I moved to personalised written feedback on test papers for every student. Yes, I am slightly masochistic, but it actually had an effect, a noticeable effect. So, I mean, it wasn't, I didn't give them essays, but the rough goal was to give them something good they did, very specific, and something that they could work on, again, something very specific. You know, it might be, you know, every time you used a formula, you said where it came from, or your setting up was great, or your reasoning was clearly expressed, or whatever, and something that they didn't do. About a third of them measurably did from that test to the next test. So I figured it was totally worth it for that many students taking it on board. I wasn't getting that sort of uptake as a tutor, but when their tutor and their marker were saying exactly the same things, then they did start listening to me as their tutor. So then it sort of went from there to, well, if they're reading what their marker has to say to them after the test, what happens if we tell them what we want before the test? So that's what happened. They got an announcement before each class test. It said the same thing every time. And it gave them a list of what they were meant to do, and it also gave them a central marking rubric. And I used a sort of holistic marking approach because we wanted a lot more than just the final answer. We wanted a reasoned argument to get to the final answer. We wanted it well presented. And so if you allocate a mark for this line, a mark for that line, it just didn't give them freedom to express themselves in their way. But so they got sort of an overall marking, and it made a big difference. For the tests where this was sent up to them in the week before, most of them, probably 2/3, 3/4 of them, put a good effort in to the things that they could do. So, you know, they still may not have been able to do the maths, but they could write it down articulately what they were doing. And the vast majority of them did make that effort. When we didn't put that announcement on, many of them didn't. So it was actually really having an effect. Back to Don.
Okay, so one of the things that kind of came from this idea that students had problems, if we just gave them solutions, and Jen, we were talking about this, you said you liked having the solutions because you could follow them. What we found was students can't, or at least our students couldn't really read or understand good mathematics from bad mathematics. And so when ChatGPT first came out, I asked it a few questions just to make sure that it wasn't going to be able to answer the questions, and it would come out with something like this. And I think I had about 6 different versions of this, so I then turned this back into a question for the students to say, okay, well, where's this gone wrong? What line is the first error on? And then rewrite this so that it's correct. And again, we still found students had difficulty articulating where the error was. Firstly, a lot of them assumed there was only one error, which, well, I suppose there is really in this, it's more logical after that. And the error varied between lines 2 and 6, you know, could be anywhere. But then to rewrite it, they often had problems. So I think from that, we then went to...
the other thing to say is if you'd just given them this question, so if you just said rearrange that thing to make C the subject, we're talking about students who generally could do that, but you couldn't give them this and have them look at it, critique it, and then fix it.
And again, this came back to the idea of communication. We're teaching engineers who have to be able to analyse somebody else's work. So this was an important part of what I consider this was an important part of what we were teaching them. So from there, I think we then went to, I had 1 week where sorry, this was the...
Yeah, that's right. So this evolved. So we did discover things from those ChatGPT questions because, I don't know, Don just, he's really good at bringing new ideas and things in and keeping up with the latest. I certainly hadn't expected the students who could do the algebra would not have, oh, the machine did it, it must be right, was kind of where it started and where it ended. So from there, the discovery was that they couldn't distinguish between good maths and bad maths, which was really interesting and quite significant because it means they can't actually learn from their lecture notes. They can't learn from the textbook if they can't tell the difference between that and chicken scribbles that their friends written. So it took a while to figure out, but it seemed like the thing that had an effect was to give them a handout with examples of good and bad written mathematics side by side for the same problem. And so simply giving even the same sheet with example 1 on one side and example 2 on the other side didn't work, but having both examples on the same side did work. It somehow gave them things close enough that they could actually notice that these two solutions are different and they could figure out why they were different. Like they couldn't make head or tail of example 1, few of us could, but they could make sense of example 2. And it started to sink in what we were trying to do with them.
So then I had a week, we had a week where I didn't have the 2-hour lecture one week because of public holiday. So we decided to do a revision tutorial. We still had a tutorial, so did a revision tutorial. But what we did that week was Merryn gave me a lot of examples from class tests where students had made mistakes or done weird stuff with the questions. I teched them up so that they all looked like they were essentially the same quality. And we got the students to play teacher for the day. So go through and identify which one of these is correct, if any, and rewrite them or identify the mistakes and how would you explain the mistakes to whoever made the mistake. And that turned out to be quite eye-opening because it was late in the term. It helped rebuild confidence, the students' confidence, because this was about week 11 in a 13-week term. But we were looking back at stuff that they'd done in weeks 2, 3, and 4. So they had a better grasp of it by then, and they were more able to then start talking about it.
Yeah, so on week 11, engagement's usually pretty awful. I had about 1/3 of my students getting really into this and just getting it. I had about 1/3 who ticked the box and 1/3 who stayed their usual unengaged selves. I had fun. It was just really fun. It was a completely different structure because it was, hi guys, today you're the teachers. I'm not. So you want something, you figure it out. And so they sort of look at the first, and there was also, it was on whiteboards. And so I guess my directives to them were, okay, so I just want you to do the first one. And then I want you to roam around, just the first one, and then roam around and have a look at what all the other groups have done. And so, of course, you get students who, and the instructions were also, it's going to be really hard to review this if you don't know how it goes first yourself. So what you've got to do before you start here is actually do the question for yourself. When you've done the question for yourself, hold up this and compare it to what you've done and see if you can see what's wrong with it and why. And so, students who couldn't do it for themselves, it's sort of, hey, miss, how do you do it? I'm not the teacher. If you're not sure, go and look at what your colleagues are doing. And it was really nice because there were a few students who couldn't do this. And after this tute, they could do it. Like, you could see light bulbs going on, and that's not something I'd seen in these tutes before. People were actually really getting something. I mean, maybe they should have had it from week 1, but they didn't, and they actually got it. And it might have taken them 20 minutes because they had to actually think about it and go and talk to other people. I think some of it was that because it was a bit of a novelty tute and there was no right or wrong, it was just you're in charge. It took that stress off them. And so they relaxed and you can't do anything wrong, you're in charge, And if you're not sure, just do a check and go with the majority vote. And it was fun. And so they did. The other thing that was interesting was I told them that they were welcome to, so they had to mark and give feedback on the board, and then they had to look at everyone else. They were welcome to give a mark if they felt like it. And there was a few classes. In one class, this turned out really interesting because someone said, "Oh, yeah, I'm going to give them 10 out of 10 for everything, just because they're poor students and they're hard done by." And so we got into a conversation about, well, actually, as an engineer, your work can be very high stakes. And I told them this sad story about a bridge that had fallen down in Israel and killed lots of people, and the chief engineer is in jail for life. And it's a true story. But so we sort of started talking about, well, maybe it's better to make mistakes now in a safe place and get things sorted out than to let people go through with misconceptions and make mistakes when it is really critical. And they totally bought into that. And suddenly the marks around the room changed from 10 out of 10 to 2 out of 10, which was interesting. The other interesting thing was that the nice effects from this tube lasted for the next couple of weeks, and then they wore off and they went back to their old selves again. But there was a bit of a lasting effect. Okay, this is, so that was one sample we gave them. This is the second example we gave them. For the records, the numbers here are all correct. The only real issues is it's not set out according to our exacting standards. And again, that was very challenging for them to try and mark, because they look at it, they do the calculation, say, well, the numbers are right. There's nothing wrong with it. Why is it here? And so, it was, well, you've got to be able to critique it. If it's right, you've got to be confident it's right and say so. But, is it good enough to give to your boss? And that was, again, just more discussion.
The we've given them right through the term was, if you're asked a question like this, then the last thing should be a sentence which answers the question that you're asked.
Mm. The pitch was, as an engineer, you're going to be contracted by non-technical people to solve their technical problems. If they could solve them, they wouldn't hire you. And so they ask you in plain English, you do the maths, but then you answer them in plain English so they can actually understand. That's part and parcel of being an engineer.
I used to see a lot of that mesh with the, particularly in statistics, where they'd be asked to do a hypothesis test, and the last line would be, we reject H null, or even worse, we accept H null. Yeah, exactly. And then because when we were doing that with mesh, a lot of them would then come up with exactly the opposite result to what the test had told them anyway. So yeah, we made that a real rule. The last thing I started doing towards the end was these test questions with built-in feedback. So again, these were numbers questions. The class tests were done in numbers online. So it was just, they were moderated in a Zoom call. They had to write up their answers, scan them and upload them. But
and
then the final exam was done in class in labs on campus with invigilation. But these were the sort of things. So typically a written exam, you'd say, okay, here's this polynomial. Find the equation of the tangent at some point, and then they just do the working, put in the tangent, and hopefully the equation of the tangent. With this one, once they put the equation of the tangent in, it draws it on the graph. So if they understand what they're doing, they're getting immediate feedback whether they need to actually do something else, whether they've got it right or wrong. Because if they don't know what they're doing, they're just going to lose the marks anyway. But it gave them a little bit more confidence in working. So that was one. And the other one, yeah, this was again, typical sort of question, the exponential growth. So you have to calculate the value of K and P naught and various other things. And then
someone's done the calculations and knows the numbers. I'm happy to put them in. I've got no idea.
The other thing with this was that you could play around. If you didn't really know what you were doing, you could actually just play around and kind of use a numeric solution of, okay, let's put some numbers in here and see what works, so that the graph, and it's in there.
Yeah, well,
a good start. Could give you the curve, so that you could then know if you were close or not. And then I didn't have the last part of this question, did I, or is it down the bottom?
yes, it's there.
So at the end, then I asked them to use, I mean, they could use the graph or they could use the formula to approximate it. But again, the idea was they then used the graph to approximate the population, in this case, for a given point in time. And the answer was set up so that there was quite a bit of freedom, you know, they didn't have to be correct to 3 decimal places. So those were some things, that's it, isn't it? Those were some things that we did in the class that we kind of felt got students a little bit more engaged. And they were, you know, they're reasonably low stakes things. They didn't take a huge amount of work. These took a bit of work to develop. But the other things didn't take a lot of work. It was just changing, I think, the expectation on the students. And once we found some things out about them, then turning that back into new type of content.